Ni hao, washi Esteban Küber. I'm going to be I'm going to be talking about the difficulty in learning Rust, the current state of the Rust toolchain, some of the potential evolution paths that the language has, the mechanisms it has today, and I'm going to propose a potential additional mechanism that we can use to evolve the Rust language. First, a little bit about me. I've been using Rust since 2015. I've been contributing to the project since 2016. I've been a member of the Rust compiler team since 2017. And the main area of focus that I've had has been on making the language and the toolchain as easy to use as possible, to try to make the toolchain talk to humans in a way that humans talk and not just like compiler engineers. That has translated into working with a lot of, putting a lot of effort on diagnostics. But a question that I get asked a lot when people are are considering using Rust for a project, or they are considering using Rust to learn, is just how easy is it? And that is a more complicated question than it looks, because there are more fundamental questions behind that. Is how easy is Rust, but easy to do what? Making one thing easier to do with a language may preclude something else to be easy to do. It's also easy for whom? Who is your expected user? It's very different to make a language for engineers than it is to make a language for people that are learning to program for the first time. Scratch, Python, Java have very different objectives. And finally, should it even be easy? And that is a weird question to ask, but is making something easier than it needs to be at the detriment of other objectives of your project may actually be a problem and land you somewhere that you don't want to be. To answer those questions properly, you actually need to understand the objectives of your language. And you need to know what Rust is in order to be able to say, is Rust easy to use? Rust is a flexible systems programming language capable of expressing high-level concepts similar to more dynamic languages. This quote is used all the time. You have seen it earlier today. It is a language, Rust is a language empowering everyone to build reliable and efficient software. We already know what a programming language is. We don't need to go into that. Empowering. What does one of the main objectives of the language is to allow people to do things. We want to make sure that every one of our users actually is able to accomplish their task. Everyone. That is a word with no classification. We are not constraining ourselves to a specific kind of user. We want to be able to support everyone, regardless of background, regardless of domain, regardless of level of expertise. Of course, we are never going to be able to be everything for everyone, but we can strive for that. And then you have to build reliable and efficient software. And that is in direct conflict with the word everyone. Because we are saying, okay, we want reliable and efficient software. And all of the things that Rust does to allow for that go in direct conflict with learnability, with the ability to do refactors. And that is part of the issue here that I want to address. Rust has certain self-imposed restrictions. It needs to be able to run everywhere. It is in my opinion, one of the languages with the biggest range of potential usage. You can write code that runs on a microcontroller, or write code that will run on somebody's browser, and pretty much anything in between. There are very few languages that actually can accomplish that. But if there is a language feature that the language could have that gets in the way of that flexibility, we're not going to be able to have it. And that is because Rust occupies a very specific niche. It is an ahead of time compiled language without a garbage collector, with memory safety, and a lot of the sign sensitivity is from more modern languages. Every other language out there has to compromise in one of these points. And for good reason. Having to fulfill all of those points means that you have to take on additional complexity. For Rust, that is worth it. Sorry. I think I'm going backwards. Okay. But because Rust is focused on performance, reliability, productivity, it means that all of these any potential feature that doesn't meet these explicit goals will be rejected. Designs that get in the way of making it easier for someone that is familiar with another language, let's say Swift, but that has a clear benefit for those objectives, might be adopted even though we are going to make things harder for some people. But we still take mitigations, as many mitigations as possible, to make them as easy to use as possible. A central ethos of Rust that isn't really talked as much as I think it should is that it is a language of contracts. For example, in Rust, there are two ways of expressing generics. We can use type parameters that get monomorphized, and that is a fancy way of saying for any type that you pass into that function, a separate function, that function will be compiled for each one of those types, and in the final binary you will have as many different copies of that code as types that were used. Whereas you can also use trait objects with dim traits, which goes through a B table, it goes through a pointer in direction, and that is, it brings a different set of trade-offs. The binary is smaller, the complexity of your code may get lowered, but it incurs a performance cost. Depending on what you're doing, you may want to choose one or the other. But if you compare this with Java, for example, where everything is a trait object, everything is going semantically going through a B table, but Java has a JVM, the virtual machine, with a just-in-time compiler that will instrument your code, look at where generics are being used over and over again, and it will actually do the equivalent of the first thing. It will monomorphize your code to make it go faster. But that is complexity at the implementation side. JVM engineers have taken on that responsibility, but the language itself is less expressive. And that is just one example of how Rust exposes complexity that is not necessarily useful for everyone. Rust is misleading. The complexity is always there. You can write a lot of code that looks very high level. You can take a snippet of Python, and sometimes you can just translate it word for word, and it will actually work. But the complexity of the language semantics are always there. And sometimes, when you stray from the easy path, you end up straight into the hard parts of the language. Like, for example, closures look very similar to the way that they look in other languages, But if you happen to be borrowing a value and then you are trying to execute that closure or pass it around, all of a sudden you have borrow checker errors that may be difficult or even impossible to actually solve without changing the way that you wrote your code. That is what happens when you are breaking one of the contracts as expressed in the code. This is a bit, I think I'm seeing different things on each screen. It's fine. It's an uneven story. The current state of the language is much better than it was back in May of 2015 when 1.0 came out. At that time, you couldn't even chain method calls. Features that would be expected because they were implied by others were added. An example is associated constants. Constants were part of 1.0, but constants in traits weren't, and they were added fairly quickly afterwards. And that evolution has continued over time. As an aside, the ease of use of Rust is not just the language itself. It includes the documentation, the toolchain, the libraries, whether the compiler diagnostics are readable and understandable. And as I said, we have been, the state of the language hasn't been static. We have moved forward, we have improved things. As time passes, more documentation is written, more libraries based on ease of use are written. The diagnostic gets better and the language evolves. The experience of learning Rust today is going to be worse than learning Rust in a year from now. There was already some, this was a little bit covered earlier by Shaq. I'm going to go quickly over it. The mechanisms through which the language evolves are somewhat varied. We have the RFC process, the request for comments mechanism, where we have a template with a bunch of sections where we try to explain what a given feature is, why we need it, what are the drawbacks of including into the language, how do we teach that feature, what are the different designs that were considered but were ignored or set aside because they didn't fit. And that process has taken us so far. It's going to continue existing and bringing us to the future, but it is very specific around a specific feature. We have the Major Change Proposal mechanism, the MCP process, which is more for tactical things, where we want to be able to refactor the compiler, or we want to be able to modify the way that a specific feature operates under the hood, but that doesn't have user visible impact. And we have the project goals that were mentioned earlier. And I'm going to go a little bit deeper into this, but they all end up into, they all conclude in result in nightly features that eventually get stabilized. For the request for comment, as I said, we have a repository with all of the RFCs that have ever been published, and that has a template that you can follow. But it doesn't start there. It starts with you. Rust's features don't just happen. Somebody has to ask for them. Somebody has to need a feature for us to even consider them and discuss them. And I'm going to give an example of somebody, a member of the project, Cobsol, who had a specific feature he had noted to make dealing with the new type pattern, which I'm not going to go into, but it's relatively simple, easier to use. And he didn't start writing an RFC. He started having conversations with people and then incorporating their feedback and those conversations into text that he wrote for himself. Then he turned that into a blog post. From that blog post, he published a pre-RFC, which is an unofficial way of saying this, I have an idea, to the rest of the community in the internals forum for people to actually discuss it. And after going through that exercise and having a lot of conversation, he actually published the RFC, it got accepted, and now it's been implemented. And that process is not something that you have to be a member of the project to do. It's just you have a specific use case, and you can bring it forward. Eventually, the language team and the compiler team, like the teams of the project, are going to discuss it and decide whether it's a good fit. The major change proposal is more internal. You don't need to know much about it. It's just a lighter weight process for people in the project to argue between ourselves for things that are going to be refactored. And then you have the project goals. Again, they have been discussed earlier. Nico started talking publicly in 2023 about them, and it's a way of expressing things that we want as part of the project, but that don't fit neatly into a single feature. To give an idea, the project goals last 6 months. That's how we've organized them. We collect the project goals into themes. The themes for this, for the current project goals, fall under 4 categories, 2 or 3 of which fall under ease of use. And under those themes, you have project goals. Under those project goals, they turn into RFCs, which will eventually be implemented. It's pretty much all of this is just a way of how we talk about features, how we talk about making a change in the language, and how we talk about evolving it. All of that results in nightly features. This is not an exhaustive list, it's just a few that I wanted to mention, but it is the way that we actually end up with something implemented. And those nightly features can be at different stages of their evolution. It may be that the implementation is almost ready and it's going to be stabilized soon. It could be that we don't yet know whether the current implementation is what we want, whether the semantics are what we want. We aren't entirely sure that the feature is actually a good fit for the language. I'm going to talk about a bunch of features. Not all of them are going to be actually part of the language necessarily, but I'm going to use them as a way of exploring some ideas. The referencing patterns is, if you know Scala, it's effectively the same thing as unapply. Is to be able to do pattern matching on pointers, even though they need to go through a dereference to actually be able to match. So in this case, we are matching on a string literal, but the variant is actually string. Today, you cannot do this. You would actually have to change the match into a series of if-lets, and in order to be able to express the same code. Another example of a feature that would be nice to have, default field values. This is already in nightly. It's on eventually it may get stabilized, but it's a way of expressing, okay, there are some fields that are mandatory, some fields that are optional. We have auto-cloning. This snippet of code today, how many of you think this would compile today? Can I see any hand if you think that this code compiles? Of course not. It's a move error. That is because in order to be able to, once you have consumed the arg, it's no longer available, and the compiler today tells you, hey, either change the function so that it doesn't consume it, or use clone. And For an arc, 90% of the time, you probably want to clone. So we could make this code to actually work for you. We have partial self-borrowing, a very common issue where people have trouble expressing concepts because there are multiple fields being accessed at the same time, and we don't have a way of changing the contract to express that without the borrow checker complaining. Generators. I'm going to skip over all of this. It's just variations on a theme. Things that the compiler could do that it doesn't do today. This is one example, return type inference. The compiler can actually do this. The compiler does it. It gives you a suggestion telling you, hey, the body of this function was an integer, just change the return type. We could actually make this be part of the language. But if we had this, it would be a big foot gun for any public API. We could do the same thing. This is even more out there. We could do inference on type parameters so you don't have to express it. All of this, I can see some people nodding their heads thinking, this is terrible, we don't need this in Rust. And you're right. We don't need a lot of these things in Rust. Some of those features are never going to happen. But what if we had something that isn't constrained by the requirements of Rust? Rust needs to be able to serve microcontrollers to web services, to distributed systems, to front-end applications. But it wasn't always a given that that was what Rust was going to be. And it could be that if we relax some of those restrictions, we could come up with a language that is effectively 99% Rust, but is actually much easier to use for a bunch of use cases. You could name that language whatever you want. The name doesn't matter. Right now, I'm calling it Easy Rust as a concept, but it doesn't have to be that. What's important is the concept, and it has been talked to death. I'm not the first person to talk about this. I'm not going to be the last. Without Boats has talked about this in the past, proposing some ideas. But what I wanted to express today is my position, because people mean different things when you say, I want an easier Rust. Again, going back to the earlier question, easier for what? Easy for whom? And personally, I have some restrictions for what easy Rust should be. It should still be Rust. It should still be interoperable with Rust. If you're taking a Rust library from Cargo, it should just work. It should be just part of the same ecosystem. It just would allow you to express things that otherwise are hard in Rust. It needs to be something, personally, I think, anything that is an error in the compiler, but that can provide a suggestion, that should be turned into warning and just allow you to continue working. But it's still a separate language. We are not talking about Rust here. This is easy Rust. As I said earlier, the compiler can do a type inference on a return type. When it works, it just tells you. Easy Rust would just accept that. An example of something that I have thought of is if you're running your test suite and you have a type error in any part of your code base, none of the tests are actually going to run. You just have to deal with that type error. What if the Rust toolchain was able to cope with that and run all of the tests that don't touch that item and then give you both the test errors and the compile error all at once instead of forcing you to solve it? And that's not even a language thing. That is a toolchain solution. Not all that makes Rust harder is just the language. There are many mechanisms for making Rust code easier to use. It's the library, the way that the library is written. If you have a lot of trade bands, that is a problem. If you have an overcomplicated library, that is a problem. If you don't have good documentation, that is a problem. And there are things that can be done from writing libraries that are easier or leveraging macros to fill some gaps. That can be done today without even a new language. But with a new language, we can go further. And having both a Rust and an easy Rust provides one clear benefit for Rust, which is we have an avenue for people to learn the language with fewer restrictions that they aren't used to. It gives you an opportunity to refactor your code. You have Rust code, a Rust project. You can switch the toolchain to say this is easy Rust now. Do your refactor, explore the Toolchain API, find the final product, and then switch back to Rust and just deal with the things that you needed to clean up. And who is this for? As I said, it's for people refactoring. It's for people that are trying to learn the language, people who are just exploring what the API should look like. And people who like most of Rust but don't care about performance. If Rust had a garbage collector, but just with enums and pattern matching, that's what I like most of Rust. That is what I use most of Rust. And there are some issues with a second language proposition. It adds complexity to the toolchain. If the second language is part of Rust C, then it means that compiler engineers have to deal with this other variation. We already have a mechanism to deal with language diversions. We have the addition system, but the additions today are purely time-based. What I'm proposing is to use the same mechanism to say this easy Rust is an addition of Rust that lasts a period of time, let's say a year. Within that year, we provide full backwards compatibility, which is not what nightly features can do. But we are going to be evolving that language quickly, where we are going to be exploring features that otherwise we would be too concerned about including into Rust. And it would also allow us to see how nightly features are actually used in the wild. And we may be able to identify things that aren't really a problem, or things that are a problem before we actually incorporate them into Rust. And because because it's a different language, it's a different stability guarantee, we can evolve much quicker and be bolder. There are other issues. Other ecosystems have tried this, and having a second language that is marketed as easier to use, some people dislike that, just have an aversion to saying, no, I don't want the training wheels in my bike, I just want a real language, and this is not that. This is a gradient. It's simultaneously a way of writing a performant code faster, but also it's a good on-ramp to be merged with Rust itself. As I said, there are many things that we already can do for evolving, but I am proposing this additional language. And what I would want is for people to get involved, even if it's not for this language, for easy Rust. Get involved with the RFC process. Get involved with the conversations in the internals forum. Get involved in the RFC threads. If there are features that you need, do speak up. That's the time I have allotted. Thank you very much.